Yes, welcome for online video session. Now, in the last video session, we have seen about behavioral model, how it works based on data and event. So some of the requirements as per as customer, it works on event, like how we have seen microwave oven, and some other examples or requirements as per as customer, it works on the data. So now we'll see the next topic, how software engineers, how they are important in collecting the requirements by the customer, and how software engineers develop the model as per as the customer requirement, how it will helpful for the implementation team to design a code by viewing the models designed by the model engineering as per as customer requirement. Myself Jagadish, Associate Professor, Department of Computer Science, Canara Engineering College, Banpur. We are seeing software engineering video session of module 3, video session number 5 as per as VTU syllabus. We have seen the context model, interaction model, structural models, behavioral models. So all these 3-4 are all models designed for the development or implementation of the code as per as the customer, which helpful for the implementation team to design the code as per as customer requirement. Now we are going to see one more model, that is model driven engineering. So it's an approach to software for the development where models act like a program or the principal output for the development process. So model driven engineering, we call MDE, model driven engineering, is an approach to software development where models rather than the programs are the principal outputs of the development process, are the principal outputs of the development process. Model driven engineering is an approach to software development where models rather than programs. So we are designing a models rather than the programs are the principal outputs of the development process. The programs that execute on a hardware software platforms are then generated automatically from the models. So, programs that executes on hardware platforms are generated automatically from the models. Proponents of model-driven engineering, that is, raises the level of abstraction in software engineering so that engineers no longer have to be concerned with programming languages. So the person who design a model driven is a level of abstraction in software engineering. There is a like a blueprint in a software engineering so that engineers doesn't have to be concerned with the programming language in detail. So the person one who know how to model the design of a requirement of the customer is more enough than knowing the programming languages. So before knowing any of the programming language, the person one who designs a product or a system should know how to model the product. So you can consider an example. So when you start constructing a house, you directly start constructing by basement. First, you will design a blueprint, that is a sketch, or you may go to the architecture, or you may go for the person who knows there is a simulation of a architecture using software, or you may have go for the model of a house first. Model in the sense as how it looks after construction of a house, how it looks, the same way the model they will make it ready. So there are some of the organizations or some of the companies are there where they design the entire house in a model type by giving how many pillars and where the rooms has to be located, which direction the kitchen has to, etc. Some such type of information they can design using models. So the person who design a product or a system doesn't know that it is not that he may or he may not know the programming languages. So even that person also able to design a model driven or a product. So usage of the model driven engineering is still at an early stage of a development, and it is unclear whether or not it will have significant effects on the software engineering practice. So something like model engineering has its something is the roots in a architecture, that is model driven architecture. We can call it as MDA, and this was proposed by the object oriented or object management groups, OMG, in the year 2011 as a new software development. And model driven engineering and model driven architecture are often seen as the same thing. Both of us looks like the same thing. The wide scope on MDA, that is model driven architecture. So it allows the system to consider at high level of abstraction. Generating a code automatically means that it is cheaper to adopt a system to new platform. So generate a code automatically. There are some of the tools are there. You can see that if .NET as well as Java. .NET, it is just drag and drop. If you drag any of the combo box or a drop down menu, just if you drop it and drop it in a platform, it's simple. Whereas if you want to drag down drop, there is drop down menu or a checkbox in a Java. You have to write a code for that. So this is what it makes it simple for the it automatically generates the code in some of the that is if you use a software like .NET or a Java like that. Models for abstractions are not necessary right for implementation. Some of the there is says as per this customer requirement, models are not necessary for implementation. Saving from generating a code may be outweighed by the cost for developing a translator for new platforms. So some of the there is you may develop a model. So to translate that model to the coding part, it requires some translator for depending upon the new platforms. For example, nowadays we have a Python and we have MATLAB and we have a machine learning, something like that, where we have a TensorFlow. So if you design a model, in that cases it's very difficult to translate the model to a new platform. So these are the do's and do not on the model driven engineering, or to design a model for a requirement of the customer. So model driven architecture, we call as it MDA, was the precursor of more general model driven engineering. MDA, model driven architecture, is a focused approach to software design and implementation. Its main focus is software design and implementation that uses subset of UML model to describe the system. It uses a subset of UML. It may use some use case diagram, like where it makes you use of a actor, and it may make uses of the context diagrams like rectangular boxes. It may use like so class diagrams as three fields like attributes field, class name, as well as operation. Such like it make use a subset of the UML model. Depending upon the application, it make use of the UML subset of UML model. Models at different levels of abstractions are created from a high-level platform-independent model. It is possible in principle to generate a working program without a manual intervention. So, it's a different level of abstractions are created from high-level platforms, independent models. So it is possible in principle to generate a program without a manual. Types of models we have. They can ask in the examination, what are the different types of model driven engineering? Or they may ask types of models in MDA. So the types of model driven engineering is, one is computational independent model, platform independent model, platform specific models. Once again I say computational independent model, or they call as a CIM. Second one is platform independent model, they may call PIM. Platform specific model, PSM. So, computational independent model, it's something like a important domain abstractions used in a system. Important domain abstraction used in a system. CIMs are sometimes called domain models, and it that is developed several different of computation independent models. They may which use it to reflecting a different views of the systems, that is based on the customer view, based on the software engineering requirement team view, and based on the implementation team. Like we have different types of views for the computational independent model, and for you can take it as an example as security of the computation independent model, in which identifying some important security abstractions or important role, which describes the abstraction of, you can take it as an abstraction of a patient as well as consultation. So patient has to view the receptionist, has to view the doctor, as well as it has been updated in the database. So depending upon the customer requirement. Coming to the second platform independent model, It is a model of the operation of the system without reference to its implementation. The PIM, platform independent model, is usually described using UML model that shows the structure, how it responds to the external and internal event. Next model, platform specific model, are the transformation of the platform independent model with separate PSM for each application platform. In principle, there may be a layer of PSM, that is platform specific models, adding some platform specific details. So you can see the MDA transformation, computational independent model and platform independent model and model specific models, platform specific model. So in this, it is computation independent model is of a domain specific guidelines. So as per as the domain, on which platform and whether it is a that is for one example I gave, no, that is depending upon the .NET as well as Java. So depending upon that domain, the translator will be added, and actors will be also act as a translator for the computation independent model. And the translator of a computation independent model will be the input for the platform independent model also. Okay, and platform independent model, that is, it is a platform specific pattern and some sort of rules will be there while designing a platform independent model, that has to be act as a translator for the platform independent model. As per as some set of rules, that is model driven engineers, one has to design the requirement as per as the set of rules and of the platforms. And platform specific model, depending upon the if the product has to be developed in specific particular languages, or there is a set of patterns will be there. So there is software engineer has to stick on to that of specific languages, rules and regulation. So whatever the product, whatever the there is models is being designed by there is a model driven engineering, all are executable code for the next implementation team. So this is what the MDA transformation. So usually we go for the platform specific model nowadays. So earlier days we are used to go for the computation independent model. So now it is a platform specific model because it's some depending upon the programming languages. So by depending on it will helpful for designing code easily for the implementation team. So multiple platform specific models. So I of course now I gave an example for Java as well as .NET. So platform independent model. So .NET specific model. So .NET is a platform. So we have a C# code generator. C# program will be designed. Whereas J2EE translator specific model, Java code translator and Java programs. So these are the platform independent model. So the code one has to be developed such a way that the code both it has to work on both for the Java as well as for the .NET, such a way that has to be designed the models. So next is on Agile methods and MDA. The developers of MDA, that is model driven architecture, claim that it is a intent to support an iterative approach to development and so can be used within Agile methods. So nowadays most of the software engineering go for the Agile methods, where iterative approaches for the development of a product, like they just do trial and error methods, and it's not that depending upon the cost also budget, first they take down the that is the code which is there in the repository depending upon the application, If it is helpful, they make use of the code which is there in the repository. Otherwise, they start developing from the scratch. The notation of a extensive upfront modeling contracts the fundamental ideas in the Agile manifesto, and few Agile developers feel comfortable with the model-driven engineering. If transformation can be completely automated and complete program generated from PIM, that is program specific PIM, platform independent model, in the principle, MDA could be used as in an agile development process, as no separate coding would be required in the agile method. So executable UML. So fundamental notation behind a model driven engineering is that automated transformation of a model to a code should be possible. So main purpose of the model driven engineering, the whatever the model it is been designed by the software engineering, is that it has been translated to code. So it make it code. There is implementation team to design a code easily. So there is a main there is foundation for fundamental for the model driven engineering, and this is possible because subset of UML 2 called executable UML or XUML. XUML is nothing but executable UML. So most of the model driven engineering, they make use of a HTML or a executable UML for designing or implementation of a requirement of the customer of the product. Features of executable UML, that is to create a subset of UML. Number of model types are therefore dramatically reduced by three key types. One is domain models, class model, and state models. Domain model identify the principal concern in a system. They are defined using UML class diagrams and includes the object attributes and associations. Class models, in which classes are defined along with their attributes and operations. State models, state diagram is associated with each class, describes the life cycle of the classes. Dynamic behavior of the system may be specified declaratively using the object constraint language OCL, what we have saw in the second model, or may be expressed using the UML action languages. So till now, whatever the models what we saw is just a to design an implementation team. We are making helpful for the design and implementation team. So now in the model driven engineering, which makes us to much more easy for the implementation team, where the coding part is also be ready by designing a model. So that one advantage is there in the model driven engineering. So executable UML are the features what is there in the UML, that is model driven engineering. So it has three key types: domain model, class models, and state models. So this will complete the online session model 3 fifth video session, and the contents of this video session is taken by the 9th edition software engineering by the author Ian Somerville as per as VTU prescribed. So thank you all.